Thank you very much for your attendance today. We're now moving into the final main session of the day. We do have one or two stragglers just coming in, which is fine. I am going to be taking this session, and it's going to be something slightly different to what we've been discussing already today. It's not directly related to iPOS, but it is, if you bear with me towards the end of this. So it's going to start off in a way that you will perhaps find hard to find relevance, but hopefully I'll be able to bring it down to land somewhere that has some relevance. So bear with me, and I hope you enjoy it. So what I'm going to be discussing today is the second machine age, prosperity, and brilliant technologies. Now, I unfortunately cannot claim this name myself. This is actually a recent book that I've read, which was written very recently, this year, released by a couple of guys from MIT. And it's an investigation, it's a study, and it's a futurist type thought pattern around the way technology is going, the way technology has existed, and the way it's affecting us in our day-to-day lives. And reading this made me start thinking about what's happening in terms of iPOS, in terms of Infor, and the way we're going at the moment. And I thought it would be interesting to just try and discuss some of that and just maybe expound a little on how we could be seeing things going. So if we think about pivotal moments in human history, what is the most pivotal or important moment? And there are a number of different things that will perhaps jump out. It could be that in order to discuss this, we have to think about criteria. What are those criteria? Is it development of prosperity for people and society in general? Is it economic output increasing? Is it social change, standards of living? You know, if we look at it from a business sense, it's revenue, it's GDP, it's things like this. So there are all sorts of ways you could define that. But if we started from the very beginning, development of Homo sapiens, humans coming along, maybe thinking about the advent of farming or the domestication of animals, those sort of things. They're all very important moments that occurred that have led us in a very quick fashion forward in a way that we weren't doing something before. It could be the modern numbering system, massive move. It actually enables to do a number of things that we couldn't do before. Numbers, well, pardon the pun. But another thing that really jumps out as moving us forward quicker than at any time previously to that was the Industrial Revolution. And if you think about the Industrial Revolution, it ran from 1760 to 1990, really, because you had quite a large expansion and time frame around the way technologies were developed and the way they moved forward. But the key thing about the Industrial Revolution was that it was all about new engines, new technologies, new abilities that were driving progress and driving us forward in terms of that prosperity and the impact of that technology. And that impact was huge. It wasn't purely around industry, it was around social, it was around the way humans interacted, it was the way we looked at quality of living. There were all sorts of reasons and means by which the Industrial Revolution moved us forward. And this, unfortunately, is James, well, no, luckily actually is James Watt. It's not me after a really bad day on support or something like that. That was a joke someone else came up with, which I didn't appreciate. So an example here is James Watt. James Watt was one of the fathers of the Industrial Revolution, and the reason for that was the reciprocating steam engine. And what this provided to us was sudden unlimited power. You could use this to achieve power for all sorts of reasons. You could remove the limitation of human muscle and human activity, and it became very quickly a general purpose technology. It wasn't about being a steam engine, it was about using this to then expand into other areas and provide a general change across mass production, across transport, across society, and expectations of what people expected as the norm. And a lot of this is about the norm. What do people expect? Where are people going in their day-to-day lives and expecting the use of technology to occur and be in front of them? So this reciprocating steam engine was very much responsible for that, but it was a slow change, a huge effect. In effect, it was the production of something that initially was very, very slow. We had a basic steam engine. It then expanded and became something that was used for other things. The effect of that on society, on the way we did business, the way we produced things, etc., accelerated over time as that became a more general use technology. And it, in effect, made a mockery of everything else that people expected before that, because it was such a big change. And it had a ripple effect. So That one technology rippled out and spawned other technologies. So once we had the steam engine, let's think about a drive belt. How can we then drive a mill? How can we automate weaving? How can we do farm activities more easily? So there's a ripple in terms of the expectation of how we do things, the technologies that are spawned from one technology, and the effect accelerated over time. So this Industrial Revolution could be regarded as the first machine age, if you think of it like that. So where I'm going with this, and it's pretty obvious, is the second machine age. Where are we at? Where are we going? What have we achieved so far? And what are the effects of that element going forward? And how is it going to drive progress and prosperity? So where are we going? So where we're at is the second machine age. Second machine age, in this book's supposition, and I think it's a very good argument, is about computers and digital technologies, and in effect what they're doing for mental activity, calculations, pattern matching, things that typically are done by humans, but the power of fine control, the way we can use it to better automate things that aren't mental and aren't related to humans, so the industrial type capability, and it's moving it forward. I have to say I'm not responsible for the Darth Vader at the end there. Someone else changed this at the last minute. Thank you, Nikki. But the point is, we're moving forward. Technology becomes very important, and this is where the second machine age is going. We're entering that second age. It's clearly... Sorry, was that a question?
No, why is he wearing wellies?
It's clearly accelerating, and it's accelerating exponentially. And this is another key tenet of where I'm going with this. It's the exponential element, the speed of increase, the speed that things are picking up and moving forward. So, before I go there, let's think about chess. Chess is actually a game that was purportedly invented in India during the Gupta Empire. And the story goes that the emperor was looking for a new game. An inventor came along and presented chess to him. And the emperor was very, very happy with chess. He thought it was a great game. So he said to the inventor, you can have any reward that you like. And the inventor turned around and said, do you know, what I would like is actually 1 grain of rice placed on the first square of my chessboard. 2 grains of rice put on the second square of my chessboard. And then continue multiplying that out for each square on the chessboard. And the emperor thought about this, and I thought, this guy is not very greedy. That's great. I'll go with that, done. And he said he would deliver this rice. But where he fell into the trap, and this is the power of exponential, is that the first squares, the first half of the board even, you can very easily think about where that's going to go. But the second you get past a certain point, the human brain can't think like that. And by the time you get to the last square of a chessboard, that actually equates to a mountain of rice. It equates to 18 quintillion grains of rice. And the story is that the inventor was beheaded. So what you do with all that rice, I don't know. But the point is that it's about exponential. That is the power of exponential. And if you start thinking about that, we come to something you're probably all aware of. You considered it's Moore's law. And this was Gordon Moore. He was one of the founders of Intel. He came up with this preset that, in effect, due to the way we can continue miniaturizing transistors, the way we can continue improving heat management, etc., chip power in computers will be increasing every 2 years, over and over again, in terms of speed, in terms of capability and power, etc. And that continued as a line, which was great. It was exponential. It just continued increasing. Now, that has slowed down. But the point is here that it's now been updated on and off to be about every 18 months. And the key is that it's not about how well we can do one thing, it's about how well we can do other things that are spawned around the edges of that. So if you think about transistor size, there is a limit. We keep going, we get them smaller and smaller, we can pack them in on the chip. But the way we can increase that is actually better heat management. We maybe stack them on top of each other instead of side by side. We'll use a material that conducts things better. So what you have is an exponential idea or technology, but there are other inventions, other technologies, other industries growing around the outside of them that then lead to a benefit to that technology. And what that means is you can start increasing things even quicker. So the Moore's Law original idea of every 2 years, suddenly it's every 18 months, keeping going, and that's not because of one technology, it's because multiple technologies are coming together to make it an exponential curve in terms of the power, the capability, etc. So that's just one idea of exponential, and it links in to the idea of the second machine age. In effect, computing power, storage, etc. is a staggering rate. It's something we can't even consider as a human. We don't see it happening that quickly. So, capability and application doesn't lag far behind the technology that does it. And it is about how you apply it and how you use it and how people consider it. So, the impact of digital technologies. It's a sudden acceleration. And it's going quicker and quicker, faster than anybody actually sees it happening, really. So, for an example, it's exceeding expectations in a non-linear fashion. If we look at Time magazine in 1982, they put on the on the cover, a computer and said the computer is the machine of the year. And that was in 1982. Now, we've come a very long way in computing and digital technology since then. We could just as easily see a Time magazine cover coming out tomorrow that had the computer, machine of the year, or the machine of the decade, or the machine of 20, 30 years. So the point here is that that expectation is the same now, but also we can do so much more than we ever started with, and the linear extension of that technology is not linear. It's exponential in terms of how we have this embedded in our lives. So computers are suddenly doing things that we really would never have considered them to do, even a few years ago. If you think about their diagnosing disease, expert systems, law systems, listening and speaking to us in a fashion that we can actually understand, and most of the time they understand us. Mind you, try ringing some helplines. But the point is, it is there, it is in front of us, and it's becoming mass usage. We've got computers writing high-quality prose. You wouldn't really think that would happen. You've got cars that can drive themselves. Google has got cars running around California, 15 of them now, that have racked up over 1 million miles. No one's really aware of this yet, but the point is the technology is there. And that is not something we would have considered even a couple of years ago. Machines are working in warehouses, running robots. Robots originally, you had to know what you were going to do. You had to know exactly where things were going to be. That's no longer the case. There's machines out there, Baxter, a company producing machines, whereby an industrial robot, I can grab its hand, move it to where something is going to be, and it learns immediately that that's what it's going to do, and then continue doing that on an exponentially powerful pattern down the workload. So that's stuff you cannot do or couldn't do before, you can now. People don't see how quickly things are developing. Now, digital technologies have been terribly bad at this in the past, and suddenly it's very, very, very good. And this is the power of exponential. And it's the power of not necessarily improvements in one technology, but others, and the coming together of those technologies. So the components of this change are myriad. Just because chips are better, because speed is better, because the way we do things is better, it's not about one of those things, it's about all of these things. So if you think about network capability, the speed of communication, the ability to link everything together, miniaturization, graphical capability. You know, what we see in front of us is so much better than it was even a few years ago. Even your iPhone now has a super AMOLED display with X number of digits. You know, these things are technologies which weren't even thought about as being consumer technologies a few years ago. It's got advanced language capabilities, abstraction layers. That's an important one. The ability to actually lift coding, which was the domain of people sitting in a dark room, to people who are perhaps unaware of the actual code. They can do something in a language humans understand intuitively, and then it will code it for you. So these are all functionalities and technologies that are growing up around the power of the chips, the speeds, etc. We have data storage capacity, retrieval speeds, the internet, the cloud, mobile, sensors, accelerometers. All of these things are important when you bring them all together, because the capability that produces is, in effect, greater than the individual technology it represents. So if we look at that, we've got broader acceptance of the possibilities. People accept all these things all the time. You now expect to see these things in every tool that you use, in your entertainment, in a day-to-day basis, when you watch your TV, on your mobile device, or your business software. And that's where I'm going with this, obviously. Mass usage. It's the ability for people to pick up. And I did say I would bring it into land at some point. Mass usage of this, gaming, you know, collaborative activities in your social networks, in Twitter, in Facebook, they're all linked together. You couldn't have that without better network speeds, better chips, etc. But the point is, you don't see individual technologies as being the benefit to you. What you see is the holistic technology with all those things brought together that represents to you as a person, as a user, etc. So, old usages, new capabilities, because we're just using them in different ways. So, if you think about your mobile device, do you remember your first mobile? Back in, mine was 1995. Pick your mobile. Are you an early adopter or a late adopter? The point is, mine had an aerial. What was SMS? Who had heard of SMS? The point is, this is back in the early 90s, whereas now we're looking at virtually everybody having a smart device. They've got voice capability, they've got apps, social media, messaging. It's all these different technologies and functionalities brought together in one unit and one unified world, which is giving us capabilities as an individual and in business which we never had before. So we accept it. If you look at voice recognition, 2004 study, 2004 said that despite decades of research, there is a recognition that voice recognition is unobtainable and not very useful, in effect. And they didn't think they'd really ever get there. Now, it's not perfect. I accept it's not perfect. But the point is, virtually everyone in the room who has an iPhone probably has used Siri or seen Siri. And there are applications that are becoming more and more commonplace. So this is a very quick extension. From 2004 to now, that's an exponential curve almost in terms of mass usage, the expectation it works to a degree, and the point is it will get better and better. So what you find is awkward in Siri, say, for example, now, it won't be in a couple of years' time. Yeah? So the point is everybody expects it, and they're using these things together due to all the individual technologies that underlie it. And what's important, it wasn't, it now is. It wasn't good, it now is, and it's a very short period of time, in less than a decade. Voice recognition is one point. The point is everything is being affected this way. So, interesting fact, PlayStation 3 has more power and capability than a Cray 2 supercomputer from 1985. And this thing filled a room, and it had great groovy lights. But the point is, that is not that long in the world of technology. If you look at the first machine age, the Industrial Revolution, we were talking between 1800s and the late 1900s, whereas this has occurred in a couple of decades. And it's not the point that it's just better, it's the fact that everyone can get one, and everyone can use it. And it's got lots of things in it. It's not about it being more powerful necessarily, it's about the fact that it has access to the internet, which now exists and is better than it was before. It's got graphic capability, it's got sensors that tell us things, it's got accelerometers, communications, light meters, multi-strand processing, etc., etc. So each of those individual technologies have progressed forward in a linear fashion, in that we slowly improve them, and if you use them for individual things, great, that works. But when you bring them together, what you have is a very powerful improvement in one particular environment, one system, one activity. So, have you heard of Waze? Anyone in the room heard of Waze? Yeah? Anyone use Waze? Yeah. Okay, so a few people. It's actually quite new, so it's picking up. But the point is, Waze is the next generation of GPS systems, in effect. Some people would debate that, but it is. And Waze actually acts differently because it updates the routes and your activities where you're going based on feedback from all its users. So in effect, if I'm using Waze and you're using Waze and everybody else is using Waze, it can tell how fast they're traveling, where they're going, what the traffic conditions are like. Is it faster than expected, less than expected, etc. So the accuracy of the information it gives you is much, much better. So instead of a dry set of calculations, which is what old GPS is, this is giving you interactive feedback, almost social activity in effect, to find out what's going on. That is not possible without the improvements in mass data handling, in GPS, in sensors, etc., as I've been sort of expounding. So the point is, it's another example where multiple technologies come together to give people a great user experience, using these things together to improve the way we do things. So what's the relevance of this? And how long have I got? I will try and keep this relatively short. So the relevance is it's not about individual technological advancement. There are many technologies improving exponentially through brute force processing power, etc., but also the way people are using it and individual industries growing up around the things that are complementary to that. So everything is moving so fast, not because we are applying Moore's law and actually adding in more processing power, etc. They are components. But the main main benefit actually, is that if you take all the individual things we can do well, bring them together, it appears to be a continuously expounding curve, and it appears that the experience we have and what we can do has increased beyond all measure, when really it hasn't. It's just we're doing it better by bringing technologies together. And what this is the power of recombination. So recombination is the taking of things we already have, using them in slightly different ways, putting them together to show something better, something different. And this is important, because recombination takes individual, brilliant, dazzling technology, each on their own path, and it means that it brings them together in a way that penetrates our activities, our social lives, our entertainment, our business systems. It changes the way we interact with them. It makes things faster. They become highly available. All of these things are internet-enabled, better looking, more intuitive, and importantly, generally accepted, and people jump on them quicker than they ever did before because they see more to what's there. So, why sudden exponential improvement capability? It's because the sum of the parts is actually worth more than the parts. So when you bring them together, the effect is more powerful than if you looked at individual things on their own. So consider this. If we think about business solutions, how does the second machine age affect this? And it affects this because there are non-linear improvements that people see based on linear improvements in individual areas of that system. So finance systems. We start this with sort of books, potentially, but you move on to green screens. Potentially there were mainframe systems. They were offline. Then we potentially move forward to Windows-driven systems, non-referential databases becoming good referential databases, and they had no integration. My first accountancy job, I was using a green screen system where when I needed to actually get a TB printed out, I needed to order it from head office, and it would come 2 days later as a printed out dot matrix paper that thick. And then I would wade through it and work out what I was doing. But the point is there was no real-time activity. It was all very horrible, green screen and yucky. If you look at reporting, listing reports, it used to be static reports, no interaction, no intuitive activity, it was batch generated, no distribution capabilities. It was a small community of users that could have access to them or indeed would even understand them because they were all very gobbledygook type reports, and they were single source. They came from one potential area and you couldn't talk to different systems. If you look at procurement, moving this towards iPOS at last, the thought of budget checking. Well, budget checking was going off and having a look at one of my printed out reports and working out where my budget was and whether or not I wanted to do something. It was all about manual capture of the orders. They were paper distribution. It was limited matching capability. And if it was done probably manually anyway. And there was no supplier interaction or document retention in relation to them. Stepping forward slowly, you've got that capability coming in. So we're now at a position far beyond that in that we can do automation of the capture, of the matching, of the distribution, document management, etc. But in this one strand, in procurement, we have a linear progression moving through these things that are related to procurement functionality. So someone says, I want an enhancement in iPOS, it's to do with procurement, it's this. And we look at it and we say, yep, maybe we'll put it in, great, it goes in. That's a linear progression. If you look at your SunSystems implementation, same sort of thing, slowly, slowly, slowly. But the point is, sometimes you get a sudden acceleration. If you look at business process management, didn't really exist a decade ago. It's coming into its own now. We've got basic workflow capability that's expanding into agile capability. It's not linear. It's got data visibility where it had none before. They are linear. But what happens when you bring, what happens when you bring this and this together? What happens when you bring finance system and procurement in a better way, using brilliant technologies and that linear progression together? That is recombination. Suddenly, you are getting a step change acceleration in what you actually achieve from your systems, what you expect from your systems, and how you can use them. So I could have put these into one funnel, but I didn't have enough room to get them in the funnel, so I didn't want everyone squinting. So these are really one funnel together, but the point is we've got different technologies coming together, unified communication options, mobile functionality. People expect that now. Multiple systems all in one area. Analytic capability, social interaction, improved workflow. They are all coming together in unified platforms that make your life better, make you more productive, increase your output, increase potentially your customer service, your revenue, and everything else related to that. That also applies to your mobile device. Think of your mobile device, everything's in there. If you think about this, it's the same concept. And the point is that we are actually moving very quickly in this direction. So if you look at iPOS, this recombination is occurring and has been occurring for a while within the procurement stack. So we have mobile approvals, XML functionality for doing matching and talking to our suppliers. We've got Ion BI analytics suddenly creeping in. You saw that discussed earlier. You've got the capability for social interaction if you include Mingle into that or bring in 3P workflow with BPM, that sort of thing. So these are functions that support and have grown up around the outside of your core procurement function, and by bringing them together, the end is bigger than all of these individual bits together. If you then consider what we're discussing earlier, what James and Roy were talking about, a lot of the theme of this day has been about the way we're looking at trying to bring all of these solutions into a fashion that is better represented to you, easily accessible, and again, recombining to give you more. So iPOS becoming more closely linked in terms of its unified look and feel, related to Mingle, related to Ion BI, etc. All of these things mean that your end experience still gives you your linear progression in iPOS functionality. You get your linear progression, and even more so, I would say, based on what Infor will be doing around your financial solution, but bring them together and it's more. You've got that community, that wisdom of the community in social. You've got the notifications, the interactions, data visibility, more agile community interaction with reports. All of these things improve your day-to-day experience and improve what you're doing as a business. So, just an example, iPOS activity deck. This is in Mingle, it's just a screenshot, but the point is we can be bringing notifications from iPOS through the notifications in the Ion activity deck. Just an example, but the point is this is where we're going. So, just some observations. You're going to kick me off with a big hook in a minute. Some observations. Some studies have shown that companies that heavily invest in IT infrastructure show a significant improvement in revenue growth over and above those that spend less. That's a fair assumption, I guess, if you accept that technologies and things are important to the way we do business. What's interesting is there's a 5-year lag in the benefits of those being realised. So you need to be looking at it now. If there's a way of moving forward and taking advantage of the step change, being on the curve exponentially, you should be. Because if you don't get on now, if you get on 2 years' time, what you have is a curve that isn't linear, it's a curve that's exponential in terms of where we're going. So start early and keep investing in it. Also, less visible investment is where the gain is. So little things actually do matter. If there's something you can do small that improves the way you're using technology, using your systems, introducing new functionality, if you're not using Punch-Out, look at Punch-Out. If you're not looking at XML, look at XML. If you want analytics, look at Ion BI, etc. Start now, because it will take a while and small things matter. So what we're looking at here is embracing the possibilities. If you were someone who potentially was on SunSystems 5, 6.1, iPOS 5.7, they were good systems individually. Move it forward. The possible now is that you can move to iPOS 5.8, Infor 10X, start using those things. Down the road, where are we going? We've got unified platforms, recombination of messaging, fully mobile capability, etc., etc. And that will only increase as we increasingly put more investment into what we can do and using the technologies better that we already have. So, second machine age, it's here now, it's in your current systems, it is something that's important. Benefit from the productivity and efficiency that you can get from bringing these systems together and use them in the right way. Don't dismiss the small gains and expect the unexpected, because something new will be there tomorrow and you need to be on that curve now. And a final example, Walmart. 1990, they introduced what was regarded as bleeding edge technology to link their individual stores together with the internet, have a better online cross-functional stock control system, which hadn't been done before. They levered cheaper central processing power because they could actually talk better over the internet. And at the time, it was regarded as unprecedented, but they were making $1 billion a week. Now, as they move forward, in 1999, they're now making $1 billion every 36 hours. And that is attributed in studies to the investment they made in the technology at an early stage. So they were looking at new technologies, recombining things and doing it better. I think we all should. And the second machine age is really important, but also more importantly to you is iPOS is moving forward, Sun is moving forward, and together, if we do it all correctly, then we're going to be on the right curve for better productivity and better revenue. And I hope that was in some way interesting. So I'll draw it to a close. Thank you.